I'm fine, thank you. Selamat pagi.
Selamat pagi.
Dana is also on. Good morning, Dana. Our good friends from the center are there. So we got good representation coming from all around ASEAN right now. It might be a little bit early for some. Ron, good to meet you. Good to see you again. It must be pretty early for you too.
Hi, good morning. I'm not putting the video, so it will be early. Yes, same here. Thank you.
Thank you for joining us again. Yeah. Just building up your trust. This equals is one representation just building up your trust. This equals is good morning. How are you?
Fine, thank you. Nice. See you again.
Representation from the universities also I see.
Yeah.
This equals is good morning.
Fine, thank you. Nice. See you again. Okay. Yeah.
This equals is good morning.
Nice, thank you. Nice. See you again. go?
Yes, we are. We got folks joining us as we speak, but
I'm sure they will. And we will have more, yeah.
Thank you, Bob. Thanks.
we can make a start.
Okay, so you will, your session will come after Pak Erwin, yeah?
Yes, we are.
Okay, thank you everyone. We have a lot of our program partners and participants with us today from around the region, and we are expecting more people will join us. Okay, today is day one of workshop 5, and the focus of today's workshop is on digital twins. All right, we trust all of you have been keeping very well since we met at the last workshop on control towers. Over the next 2 days, you will be meeting some very distinguished speakers invited from NUS as well as from the industry. All right, and they will share with you their very extensive knowledge and experiences. And as we have shared with you at the past workshops, your very active participation in the workshop will contribute a lot to making this workshop and the program a success. So please feel free to interact with the speakers. All right, share your questions and your comments during the question and answer sessions. All right, next we would like to invite Pak Erwin. Pak Erwin, our very good program partner and friend from Indonesia. He is the assistant to the Deputy Coordinating Minister for National Logistics Development from the Coordinating Ministry for Economic Affairs, Indonesia. Pak Erwin, if you are ready.
Okay, thank you, Yo Yong.
Thank you, Pak Erwin.
Can you hear my voice clearly?
Yes, we can.
Yes, we can, Pak Erwin.
Can we start now?
Yes, please, Pak Erwin. Please go ahead.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya. Good morning. May peace upon us all. Actually, the team of National University of Singapore and Coordinating Ministry for Economic Affairs have already prepared my speech today. So in this occasion, I just read it. Let's start my speech. The Honorable Dr. Robert De Souza, Executive Director of the Logistics Institute, Asia Pacific, National University of Singapore, and team also Hyo Yong here, Hyong Sia, and Andias, and Professor Lee Lo Hei, Center Director, Center for Next Generation Logistics, National University of Singapore, and also Dr. Tan Pui Liu, Director of Syntec, Agency for Science, Technology and Research, Easter Singapore, and also Anatoly Zarepsov, Product Manager, Any Logistics, and I see here also from AHA Center, Grainor Tanya. Good morning, and distinguished guests, ladies and gentlemen. On behalf of Coordinating Ministry for Economic Affairs, I would like to welcome you all to the workshop 5 on digital twins, analytics, optimization, simulation. This workshop is part of a series of online workshops with the theme Digital Urban Logistics Program in Southeast Asia. This very exciting program is co-organized by National University of Singapore, the Logistics Institute Asia Pacific, and coordinating Ministry for Economic Affairs, and fully supported by Temasek Foundation International. I'm very happy to see so many participants from our partner organization in Indonesia and the region attending this workshop. I know you have made very great efforts to participate in the earlier workshop, and from your very positive feedback, I am heartened to know that you have gained smart learning. I am confident you will find this workshop and the upcoming ones equally interesting and rewarding. Distinguished guests, ladies and gentlemen, we know that the COVID-19 pandemic has been a strong catalyst and impetus in exposing the critical need for business and commerce to further digitalize and explore usage of new technologies. Digitalization in the logistics and supply chain industry plays a crucial role in the processing and coordination operation and orders in a timely, targeted, and expeditious manner. The digital urban logistics training program is especially relevant and important given the challenging times brought about by the COVID-19 pandemic. The program was conceived with the aim of enabling you to gain knowledge in digital supply chain management thinking and practice through a defined series of online engagement and training sessions. The program will inform, build capability, and deliver implementable outcomes. This program will also provide the impetus in connecting people and understanding of logistics through sharing the region experience in digital logistic connectivity. Through a series of online workshops, we hope to facilitate efficient logistics and overcome the barriers of mobility that hinder integration in the Southeast Asia community. Distinguished guests, ladies and gentlemen, I'm sure all participants have already attended the previous workshop on an overview of digital urban logistics in Southeast Asia and control tower, visualization, supply chain analytics, and performance dashboarding. The focus of the workshop over next 2 days will be on digital twins, as mentioned by Yu Yong, analytics, optimization, and simulation. The workshop will cover the exciting topics including digital warehousing twin, digital twin and collaboration decision making, network optimization, master planning, use case on digital twin simulation, simulation analysis, inventory optimization, and risk analysis. I would like also to let you know that the upcoming workshop, the next workshop, are equally exciting and will cover including topics, advanced technologies in supply chain management, supply chain risk, blockchain, quantum computing, and artificial intelligence, machine learning, supply chain thinking and digital practice, learning by serious gaming. That is why in this occasion, I urge you to value this great learning opportunity and continue to attend. Again, don't forget to continue to attend and participate actively in all the workshops. Distinguished Ladies and gentlemen, this program would not have been possible without the strong support and partnership of Temasek Foundation International, Singapore. We are grateful that Temasek Foundation has enabled us to deepen our relationship with National University of Singapore and the other regional partners over the years. Together, we have implemented some very effective and meaningful programs. We hope to continue collaborating with Temasek Foundation in developing capacity and capabilities of human capital in logistics and supply chain for better future. Lastly, on behalf of Coordinating Ministry for Economic Affairs, I would like to express our appreciation again for all the program partners and participants for your support and friendship. We look forward to a very meaningful journey ahead. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. That's all my speech. Thank you.
Thank you very much, Pak Erwin, for your welcome remarks. Thank you. Next, we would like to invite Dr. D'Souza. Dr. D'Souza will set the stage for the next 2 days. Dr. D'Souza, if you are ready.
Okay. Thank you, Pak Erwin, as a good friend and being instrumental in helping us over the good many years in so many activities, not only with Temasek but with many other activities. We look forward intently to collaborating in many more to come. Yeah, we have some good activities upcoming with all of you, and I look forward to engaging. Now, if only Pak Erwin actually described the activities ahead of us and the intent of the program extremely well. So I will not reiterate that, but I just want to set the stage for you. This is workshop 5, and as you know, we did the first 2 workshops. These are 2 separate programs that are being brought together. One is on digital urban logistics, and the other one is essentially on humanitarian logistics. And the 2 have come together, and because, like I said to you, we had the first 2 sessions to launch each of these activities. We then had 2 workshops of 2 days each on the control tower, where we introduced to you several excellent companies and speakers who actually had engaged in what is a control tower. And then in this workshop 4, we elaborated on how the control tower could be used very specifically in humanitarian logistics. Now, when we turn to workshop 5, and you remember when I introduced in the opening sessions in the first 2 workshops, we are going through the digitalization of this space, and that's why we got a very good attendance from a region. And I said to you that we started off with the digital control tower, and now we are moving on to the digital twins and still relating it back to what the control tower should do. Yeah. Digital twins are very important, and I will not steal the thunder from my colleagues who will talk more about it. Yeah, but digital twins are very important, and for that we have very good speakers, some of the best speakers, if not the best speakers that I've encountered, and they will actually only introduce the topic of digital twins to you, but they will also in this workshop set the stage for what digital twins could be applied to. Yeah. In workshop 6, we will look at more applications of the digital twin. Yeah.
Dilakukan dimintakan persetujuan KLHS, proses penyusunan KLHS. Nah ini kita sebenarnya kajian, kemudian kita juga nanti mau rapat-rapat melakukan pemantauan ke ETTR.
Okay, so today we will actually have Professor Lee Lu-hei. Lu-hei is the center director, and he will talk to us about a very good application, a very good use of digital twins within warehousing. Yeah, and I know the center. We work very closely with the center. We allied to the center, and this is something I want to introduce you to. Yes, so Professor Lee will talk about that. Dr. Tan from Simtech is a very long time collaborator with the Institute too, and we do a lot of good research work together. And she will talk about the digital twin applications that she has built here, and you will see that in practice too. Yeah, so very, very good speakers this morning. After lunch, because we had to put them after lunch, because they will be joining us from Russia. The folks from AnyLogic need no introduction. AnyLogic is one of the leading software simulation software environments in the world, and the HQ is in Russia, and the management of including the CEO of the company, AnyLogic, is a very long time friend, and he has in the last few years they have come up with a tool called AnyLogistics, and the leader of that team, his name is Anatoly. Anatoly has been associated with the Institute for good many years. In fact, ever since the start of AnyLogistics, yeah, we have been one of the first users. And so when you look at it, his team and our team work very well together, and we look to sharing that knowledge with you. So Anatoly will join us this afternoon and tomorrow afternoon too. Yeah. So he'll join us from Russia online, and that would be very good. So tomorrow we will also share with you some of the work that we did in the Institute. So Giuseppe, Zaba, myself, we will actually share with you what we have done in the Institute using some of the tools like AnyLogistics, as well as tools that we have built internally in the Institute on visualization. Yeah. So without much, I want to just to introduce you to workshop 5 and workshop 6. So workshop 5 is actually on digital twinning. So I want to hand back to the programs, and as you all know me, and I know most of you now, and I know most of you in person from the past year. It's a shame that we can't run these activities with you. We would have run them, but here we're getting audience from across the region, virtually every country in ASEAN. Yeah, and because it's Temasek Foundation supporting ASEAN, we don't have that many from Singapore because it's meant for countries outside of Singapore. Yeah. So with that in mind, thank you all good friends for joining us and staying with the activity. I want to hand back to Yong so that he can introduce the next speaker. And I apologize to Prof. Lee because we're running a little bit, by 5 minutes later than planned. Yeah. So thank you. Yong?
Thank you, Bob. As Dr. D'Souza has mentioned, our next speaker is Professor Lee Lu-hei, who is the Center Director for the Center for Next Generation Logistics, NUS. Professor Lee, if you are ready.
Yes, okay, thank you. Thank you, Yongjia, for the introductions. Selamat pagi. So really very honored to have the opportunity to share some of the work that we have been doing. So what my plan today is actually to introduce the digital twin work that we've been doing, and also trying to introduce some of the concept that we believe the digital twin should push forward. And I also want to introduce a bit on the academy in terms of really what kind of technology and ethics skill that we are developing in order to realize the dream of this digital twin. And finally, we show certain use case that we have been doing with some of the company. And lastly, even though now I'm focused on the warehouse, so I'm going to also introduce some of the work that we've been doing in the container port, where we really help Singapore to advance the next generation port. So in this era. So in short, today what I want to show you quite many things, but of course I was trying to control my timing so that you will not into the lunch and also the timing for PS, which is my best friend as well. So anyway, today we are talking about the digital twin for the warehouse. So let me try to very fast to talk about what is actually happened for the digital twin. And then essentially one of the whole idea here about the digital twin is actually, we look into the logistics sector for Singapore, that one of the main challenges that we talk about traditional warehousing is actually is kind of very time consuming, and also it's a labor intensive, it's a land intensive, and many of the time that one of the challenges is a shortage of labor and scarcity of the land, especially for Singapore. We know that each piece of land is so precious, and we also lack of a manpower. So if you really look into traditional warehousing, if you continue to push forward the warehousing, and this is some of the challenges they were to face. But on the other hand, if we really look into one of the potential technology out there, of course we know automation and robotic are the potential solution that can be implemented in the warehouse. And there are so many different kind of automation solutions out there. But if you really look into more details, actually also realize that automation robotic is not only the solution, but however, how are we going to exploit the technology? And it means we need to look into other aspects of technology, the Smart Nation initiative, as well as how can we make full use of the data, so that today when we're trying to embed the so-called automation robotic in my system, I'm able to utilize its capability to the full extent. Okay, so because of that, actually one of the important issue that we were talking to our industry player from EDB and introduced to many of the industry player. So one of the challenges they are facing is, yes, they heard about automation, and some of them already using certain automation and robotic system in their warehouse. But one of the common problem and common issue that they are facing is there are so many different type of the automation system, and how should they choose? And should they choose only a single type of automation system, or should they choose a combination of the automation system, or should they be certain part is automated while certain part is a manual? And then from one of feedback from one of a good friend of mine who is owning a warehouse and working with a 3PL, and actually the comment from them is when they start to set out the warehouse, actually they are advised to install certain type of automated system, but at the end of the day they found out that the utilization for that automated system is actually very low utilization, and at the end of the day it turned out to be a white elephant. And also, I have been talking to another retailer, also shared a similar story. They say that, yes, they have embedded the so-called automated system. And however, the automated system they embed is not help them to deal with those fast-turning kind of the goods. So instead, they're using it to store some of the slow-moving goods, which surprised me because ideally, automated system is supposed to support the e-commerce and a lot of the fast-moving, and why it turned out to be supporting the slow-moving goods. So maybe one of the main issue here is, do they choose the right automated system, or should they consider the automated system in a more holistic way so that they are able to exploit the full advantages of those robotic systems that they're embedding? Of course, another question come in place is, what are the capacity of a storage system? And how do they store the systems in such a way that the robotic system can utilize the best so-called the advantages? And again, what is the layout, what is the configuration, what is the number of equipment, or even if they need to have certain manpower to be embedded in the system, and how do they actually embed those people in, and how do they really optimize in terms of the resource? And at the end of the day, you can say that how do they make the best design, and how do they pick the best design? So that come into one thing that we want to introduce is actually we all knowing that now we are in the era of the industry 4.0, and then nowadays we are not talking about in the new phases or the old timing that you control the system separately. But however, the industry 4.0 it bring a new era of a new technology that we can exploit on. But if you pay more attention to what kind of a technology actually available here, you find out that, of course, one thing that come into here is the Internet of Things, and which is actually one of the very exciting things that are going to happen in future, or it's already happened now. The main reason is because now we are not only using human to communicate through the communication network, but now even the devices is able to communicate through the communication network. So with the outcoming of a 5G network, so we might be able to see that the exploitation of using the Internet of Things will be a fullest. So on the other hand, we also talk about automation, and then we talk about, since the Internet of Things, it bring the sensor and it bring many of information and data here. So now we have to start to look into how can we better utilize the data, and how are we able to utilize the technique and the research in the artificial intelligence and deep learning in order to make a full impact. But if you pay a more deeper thought about what is actually happening in this technology, actually realize that Internet of Things is more like our organ, it's our sensor to the real world. So it's more like our eyes, our ears, our mouth. So it's actually capture, it can be a visions, knowledge that we get, it can be a temperature, or it can be some kind of a real-time environment data that we can get out from Internet of Things. So this information is actually our sensor. So today, if we are able to sense what is actually happened in the real world, so it's actually more like some data that we are actually able to collect. But on the other hand, we find out that in order for us to utilize the data, we need to have a brain, we need to have a memory, and we have to process the information. And this is where the AI, big data, deep learning is actually trying to capture. But on the other hand, we also need to have the automation or the robotic to help us to carry out the task, which is like our hands and legs. So these are all the technology which is available there. But let me ask a question, what is actually still missing? And then, of course, one of the things that I think is missing is actually, can we have a body which to combine and to consolidate all the function that we are doing? Means our eyes, our ears, our mouth collect the data, and while our brain need to have something to combine together all these functions. And importantly, we need to have a mind that tries to coordinate the function of all these organ activity, and which is actually kind of very important, and that's why I call mind. And finally, I have a vision, not only trying to coordinate, but can we try to make the system more intelligent? Something like they have a show. No, it's not just like a menu which when you feel hungry, you eat, and then when you feel that you're tired, you sleep, and then rather you have a purpose in your life, and this purpose is drive how your life are going to be, and then you're going to make contribution to the society and your purpose of the life. So similarly, today if you look at the system, do we embed the system with a certain show, with a certain purpose, so that the show is able to think, able to utilize the kind of information that they collect, and can generate a lot of more data, more information they want, and at the end of the day, they are driving the system to evolve to a better self. And this is what I call a digital twin, which able to not only trying to link all the functions together, not only have to coordinate all the functions together, but importantly, you have a show, you have a thinking that lead the system to be evolved in the better self. And this is what we call about digital twins. But of course, what is actually a digital twin? And many people are talking about that digital twin is just about a digital manifestation for the physical system. So in some sense, it's correct. It means I have a physical system. And how am I going to make use of a digitalization and to collect all the data, information about the physical system and store in the digital world? And now, when you talk about digital manifestation, then something very interesting about that is, do I have only a single way to manifest the physical system, or should I have a multiple way of how the physical system should be manifest in the digital world? So that comes into something very interesting, that if you look at the physical system, they are limited by time. limited by space, and limited by a lot of physical limit that we can envisage. But however, if we look into the digital world, they are not limited by all this. So why? It's because if you look at the digital world, that they can go to the past, they can go to the future, and they can even go to the world that have not happened yet. So that's why the digital world is much more relaxed compared to the physical system. And because of that, when we talk about digital manifestation, it should not be just limited to a single way to manifest the data and the information, but it should be a multiple way. And in other ways, you can also envisage that a digital twin can potentially be a digital data warehouse for the physical system that you have, but also these data are not limited to some, I call the numbers, but can also be a relationship and an activity relationship, and even some of the future objective and future scenario things that you want to encompass on. So because of that, it means what? It means when you look at digital twin today, it should not be a single model to manifest, but it should be a multiple way on how the data and how the system to be manifest in the digital environment. So let me try to highlight a point about a digital twin. So in this case, how digital twin can add into what we are doing currently. So I know that in our current world, the control system have been very extensive and have been applied in many of the area. Like for example, how are we going to fly to the outer space? Even back in the 1960s. So it's because of the advancement in the control system. And the general concept about the control system is if you're able to observe what I'm going to get from the system, and then I can have this control policy in such a way that I should be adjust my so-called the control variable in such a way that my system is still can be in control. So this is actually what we mean by the control system. So it means it's a closed loop control. So you observe the system output. If the system output is deviate from what you want, then you're trying to adjust your control in such a way you can go back to the norm. However, what digital twin is able to provide is he able to provide a lot of potential scenario that are going to happen in future. So in other ways, it's not only limited to your observation, it's not only limited to what you see, but it can also be some of the future things that you can have. So because of that, when you go back to the control policy, you have much more things that you can look for. It's not only what is actually happening now, but it can also be something that can be potentially happen in the future. At the end of the day, you can have a much better control policy over the system. If you look at the first system here, which is actually this control system, so for this first system, the whole idea here is you always lag behind the changes. So in other words, when there are some changes, you're always trying to run after the changes. But however, for the second system, one good thing is you're not only run after the changes, but sometimes you can even be proactive. Before the changes happen, you already know how you should do, so that it can be well prepared. And sometimes it can also change the system so that some of the changes will never be happen. Okay, let me use one of the example to illustrate how this can be worked. Okay, one of the interesting things which is actually happened is or I would call it that like 2 years or actually last year. So you still remember that when the COVID-19 start to hit our region, I still remember that during January last year. So when it start coming, and then one of the challenges that we are facing is we don't know how bad that situation will be. So of course, at that time, being in Singapore, we feel quite safe. It's because that we have this SARS experience, and this SARS experience tells us that how should we quarantine the people, and how should we control, how should we set into certain control measure in such a way that we can control the disease so that it will not be widespread. But it turned out to be what we learned from the SARS are not able to directly applicable to this COVID-19 spread. The main reason is because the spreading of the COVID-19 is much more serious compared to the SARS. Is because even without the symptom, the disease already starts to spread. So that's why at that time we are caught off guard, and because of that, then suddenly our number go out highly, and then there's a lot of enhanced measures start to come and to curb down. So now we start to go to the normal phase, which we finally able to overcome such a disease. But today, if we're trying to look back into what happened when the start of this COVID-19, if today we have a digital twin which can look into a lot of possible situation and then which might happen. In other words, we can use based on what we learned from the SARS, but however, ask the question, how about if the disease is much more serious compared to the SARS, and maybe is more, the spreading pattern is different than the SARS, and how can I do? What can I do? What kind of impact it can be have? And this is where the digital twin can bring in some of the potential scenario which might not happen, which might be even worse than what has happened in the past. Then we can start to learn, and so that we can react to the situation much faster rather than we always changes over the situation. So in summary, what I want to highlight here is when today we have a digital twin, it means we have a tool which we not only trying to rely on the past and now, but we can also actively look into the future, and in the sense that we can actually be more well prepared. So that comes to one of the idea of a digital twin is it should look into the past, means the historical data, give you certain basis, and it should look into a current situation, let you to know where you are. And based on this historical data and where you are, then you fit into the digital twin, and this digital twin, it will create some kind of the relationship between what is actually happened now and trying to be actively to look into what are the possible future that you are going to end up. And based on this possible future, what you can do is you can try to optimize based on this possible future. And something what I want to highlight here is, and many times when things occur, we always firefighting. No, why? Because we don't have time. So when the situation happens, I say, hey, what should I do? So I should firefight to find the best way to do. So I use my gut feeling, use my experience, and to settle it, one by one. However, if today the disruption or the issue not happen yet, but yet I borrow the time from future, since I have not had time because the things have not happened yet, then I can do a lot of evaluation, a lot optimize, and then based on that, I can try to optimize my future. And based on this optimized future and the real-time data I have and the past historical data, then I can start to learn. So in other ways, my artificial intelligence or augmented intelligence or AI, what I trying to learn is not only trying to learn from my past, which is history, not only trying to learn from my current, which is my information I got from my IoT and the sensor, and also some other information I received, but also it's trying to learn from all the future that are going to happen. And since my artificial intelligence is able to learn from the past, from the present, from the future, then he can create a super brain, which essentially can go to advise my digital twin or even try to advise my physical system on how it should evolve and how he should make it better in such a way that the system is able to evolve to a better self. And this is actually what we believe the digital twin is able to bring to the table. So because of that, when we talk about digital twins concept, that is where the 4 dimensions of a digital twin that we want to introduce here. Of course, I understand that many of the industry players, as well as many of the research institute, or even some of the different sectors, they have tried to implement the digital twin concept. But as I want to highlight that if you really look at the type of digital twin concept they implement, in general, there are 4 dimensions that they're always trying to implement the digital twin. And the first dimension is what we call visualization. And the second dimension is connectivity. And the third dimension is analyzability. And the final dimension is called the granularity. Okay, the first dimension, visualization. Actually, what it means? It means today, if I can make use of my Internet of Things, and then I make use of my digitalization, and today I'm able to display and collect the data from different sources of information, and then I'm using a certain dashboard to display my data, or maybe even using certain animation to display where my information is, or even using some virtual reality, mixed reality, or augmented reality to help me to display some information. And this is the one aspect of a digital twin. Of course, one of the application for this visualization can be we replace the control tower by using a digital twin. So what does that mean? I mean, in future, if today we talk about the for example the airport control, the air tower control. So for example, now today, if you look at the airport, we're trying to build our control tower, which is high, which is able to oversee the whole airport. So why we need to do that? Because at the end of the day, we need to have those person who are sitting in the control tower to control all the aircraft, and when they should taxi in, when should they go out, and so that they are able to coordinate the flight in such a way that no accident are going to happen. But however, if you would like to implement the digital twin, make use of the so-called video and do a right scheme, and also make use of all the sensor data for all the flight, and also make use of the underlying data, like how many passengers carry, where is your flight, and what is the status of each aircraft. And actually, we don't really need to sit the so-called airport control tower at the airport, but it can be at the remote office. And then what we can have is to create the screen which have all the monitor to display what is actually happened real time in the so-called airport. And at the end of the day, what we are doing is we can even using augmented reality to display all the aircraft in terms of the information, and then whether there's certain maintenance issue, whether there's some error, or whether they clear the taxi runway, and we have all this information displayed, and together with this augmented reality, and then the controller will do a much better job. And then often underlying there's a lot of computation that's going on, so that in that case it's purely a visualization, but it can realize a digital twin for the airport control tower, which not necessarily have to be seated in the airport, but it can be at the remote area. And why it can be done? Because again, all the information have been transmitted into this so-called control tower, and it have a full sense of what is actually happened. And not only the visual have a full sense, but there's a lot of data to support the controller to make a much better decision. So that is something quite exciting. And again, this is an aspect of visualization. So the second aspect is about the connectivity. Of course, the whole idea here is because now we have a lot of sensors, like for example, again, using this airport control tower as example. So all the machines and all the aircraft are having equipped with IoT and able to communicate and about the real-time data and real-time situation about, for example, the engine status, and whether all the part is in place, and whether the aircraft is ready for departing, or whether there are any small minor issue here and there. So when all this information are communicated to the whole system, and then we have a better view not only about the whole airport, what is the situation, but even I can go down to every single machine, what is actually happening now. And with this information connect down, then actually I can do a better way and to make decision. So together, visualization of connectivity is actually quite powerful because it can actually embed the information so that the user can make a better decision. So that is the two aspect that usually people can visualize and can imagine. But also, I also want to introduce another two dimension, which is the analyzability as well as the granularity. So for analyzability, something that I want to introduce here is because since I have so much information and so much data, do I just to display out and then let the human to make decision? Can I actually do more analysis for the data to gain more information and use this information to even optimize it so that I can assist the human in making better decisions? And this is where analyzability comes into picture. And also, not only using this data to help you to display, make decision, but can also try to generate a lot of the future data. This is where the simulation comes to picture, and also you need to do optimization at the same time so that you can analyze not only based on the current data, past data, but also data from simulation, future scenario. Then you can do a much better simulation analytic. And then the powerful is you are going to let the user to have much more tool and much more information then guide them to make a decision. And not only to making a decision now, but they can also advise how the system should change for the future. So that, as I mentioned, that system become a thinking system. It's not just a passive system to display the information, but it can be an active system to advise the system how should he evolve himself to be a better self. And in order to do that, we need to bring in analyzability dimension. And we also need to enhance our capability in doing things right and doing things better. And this is the dimension of analyzability that I want to introduce. And this dimension actually need a lot of research in terms of optimization, simulation optimization, analytics, which can try to enhance and make it even better, even more encompassing. And final dimension I want to mention is a granularity. And that is actually come back to one of the things usually people have this misconception saying that digitalization is a precise and exact representation of a physical system. My answer to that is usually yes or no. Yes, on one hand, I want to have a precise and 100% representation for the physical system. But on the other hand, I also want to have some other different type of representation. It can be a rough scale. It can look into a certain aspect. It can be very localized, or it can be even a more high level. So in other words, because as I mentioned just now, if today I want my digital twin to have a thinking and to have an objective to drive itself to be evolved in the better self, then it means I need to make sure that I have a multiple model at the same time exist in my digital twin so that they can deal with different data, they can deal with different relationship and making a different decision at a different time. Because and that's what we always can say, that in terms of my digital twin, it can have a conceptual model, it can have an operation model, and it can have a very exact model which exists at the same time. And something good about my digital twin is because all these models make use of a common data and information that I have, and all the data and learning that we learn from each other, they are able to communicate and they're able to make sure that it all works together. And this is the part which actually are making the so-called digital twin different. So in summary, when we talk about digital twin, it's not just about visualize, not about just connecting the data and display it, but rather are we able to increase the analyzability dimension as well as the granularity dimension so that we have a lot more tool to use, we have a lot more data to exploit, and then we can make a much better decision based on the different objective that I want. So what is a note that I want to say that? Okay, digital twin is not just only a 3D model. Yeah, it can be a 3D model, but it's not only a 3D model. And digital twin should not be a single manifestation. It should be a multiple way, and it really depends on the purpose. And my emphasis about a twin is always can combine the right module, the right data, and right information so that it can help you to answer to the question, can help you to deal with the situation that you are facing. And because of that, I always like to see some science movie. One of the movie I like a lot is like Transformer. So I believe that if a future situation is more like a monster, they are going to come. If today I have a digital twin, can I try to, like a transformer, I can combine different modules together and build a robot that can fight the monster according to the feature and characteristic that the monster displays. And this is the part we talk about the digital twin. So my envision for the digital twin, it should not be just a single model, but it's a knowledge hub. It consists of the human knowledge and it also consists of a lot of knowledge that we learn in the digital twin itself. And this knowledge and the data and the model and optimization together can help us to fight the future monster that are yet to come so that we can evolve the system to a better self. And of course, in order to do that, one of the challenging, interesting idea here is the model itself should be self-evolved and should be self-learning, and which also lie down to many of the areas that we did on the machine learning can help in this regard. So that's why I want to dive in a bit more on this analyzability. Means it's actually digital twin enable data analytics. And we know that actually why we need data. Actually, the data is because we collect the data. As I mentioned, now with the coming of a 5G era, we know that data collection is no longer an issue. I mean, in the past, it's very difficult for me to collect all the machine data, all this. But now with the 5G coming, that should not be an issue. And secondly, is from the data, we always say that we do analytics to discover the knowledge from the data so that we understand the relationship between the data. That is the second level. However, can we make use of the data to create new knowledge? And this knowledge is actually about future scenario and new knowledge about how we should run our system and how should we evolve a system to a better self. And in order to do that, actually, we bring in one thing very important. What can the analytic help when you look at the data? And I always say that analytics can help us to monetizing the data. Means I can actually quantifying the value of a data bring to me. And also, not only quantifying, but can we actually create value through the model generated data. Means if I can use my data twin to create a lot more data, and then I can create future value. And this value is not only the what I collected, but also value for future. And this is something exciting about that. So we all know that world champion world machine beat the world champion. But actually, if you dig down into what actually happened, this Go Alpha, actually Go Alpha is just a deterministic game. And then, but however, the number of moves is so huge that people believe that machine is not able to beat. And that's why people start to using the deep learning, and then also using multi-color tree search and neural network together to do it. And actually, what is actually using in the Go Alpha, how the machine beat the world champion is very simple. And what he did is actually using sampling. Means he's trying to play the game. So this is a bit more like simulation. And also, he made use of the experience, the best player experience, to see that how should you react and how once react if you see the chessboard in a certain configuration. And then also using the best player the experience as well as the optimization to guess the opponent move. Of course, he tried to using the neural network, trying to find the relationship between these trying to find the so-called neural network to find the relationship between a certain board and how people are going to play the chess, as well as trying to see that what are the chances they are going to win given a certain chess configuration. So in summary, if you really look into why it works, it's because there are three important components in the machine learning and the Go Alpha here. It's not only the learning part, because learning is learned from data, but he also, and the other two important components, one is I call simulation, means trying to play out a lot scenario, and the other part is actually optimization. And then, and of course, if you hear about if you follow about the news about how this world champion beat the machine beat the world champion, and when they're trying to compete with this Korean player, I remember that the Go Alpha actually lose one game. So, and why that Go Alpha lose that game? Because at that time, the world champion do a move that usually people don't move. And because of that, the Go Alpha suddenly don't know what is the right optimization to do. And so on the spot, when he's trying to do the learning and simulation optimization at the spot, because there's so many possibilities, and that's why he's not able to keep up with that. And because of that, he's actually losing. Okay, in other words, is because if you only learn at the spot, actually most of the time you might not be able to success. And however, if the world champion want to play the same move again to the Go Alpha, he will definitely lose. Why? Because after that, Go Alpha know about the move, and then he can make use of other time to learn and learn and learn the optimize. So that's why next time if you play a similar move, I know how should I react to that. So that is actually what I mean by borrow time from future. And that's why what Go Alpha is doing is during his time that he don't play the game, he's always trying to train himself, always trying to learn from a lot of moves, and that because of machine, always believe and always remember the kind of history and what he had played before, and that's what he can be so successful. So what we have learned from this Go Alpha is three things. Is first of all, we need to learn, but not only learn from a past and his data, but we can have to continue to run the scenario and run simulation, optimize the simulation continuously, so that we can always learn not only from a past, but also learn from your better future. So that comes to something that our group is trying to do. We call it simulation analytics. So this simulation analytics, the basic concept here is we not only learn from a past and a present, because if you learn from a past, usually you learn from a past failure so that you don't commit the same mistake again. But if you can actively learn from future, then you can be more past active learning, and because you want to learn for success. So that's why I always say the simulation analytics is to help us to learn from future for the future, because we want to learn for success. But of course, what is a future? And many people say about future, part of future can be the data that can help, means it depends on the present. And part of the future actually depends on some event that are going to happen in the future. And sometimes this event could happen in the future, you might need to have certain human to jump the gun, to come in, to propose something. No, there might be some potential scenario. You see, because sometimes don't know whether it's you don't need to worry about whether it's reasonable or not reasonable, because we are running a scenario. We can always try to open up our imagination, to be all possible future. Then we can try to learn. of course, no matter what, you find out that your future is always full of surprises. So because of that, I can generate a lot of scenario. So that comes to something that I always want to highlight. You know, in our field, a lot of time we talk about that we want to do a good forecasting. And many of people, company come to find me, hey, Prof, can you help me to find a good forecasting tool? Frankly speaking, forecasting is one of the very, very difficult situation. Why? Because you want to forecast only a single occurrence, which is very difficult because future depend on so many things, and a lot of future also depend on surprises. So that's why instead of saying that I want to forecast only a single scenario, so a better way is what are the possible future that can happen, and based on this possible future, I try to prepare myself. So that is another dimension for the forecast. Instead of put all your egg into a basket, I should try to diversify. And how I diversify in a more informed choice means I look at all the possible future that can happen, and then I try to prepare myself. So that is a similar. When you look at the future, it's not only a single future, but it can be a multiple future we look at. Then based on the multiple future, then we can try to run simulation, and we can try to optimize the simulation accordingly using a technique called simulation optimization. And finally, we can find optimal decision, and then that can generate a training sample for us to learn a so-called rule. And this rule can help us to evolve ourselves to a better self. So this is a very, very high level that I'm trying to envisage here. So essentially, this will actually exploit the full advantages of what Data Twin is going to bring to us. Of course, now let me try to bring something into a more theoretical in terms of the academia. I'm not sure whether there are any academia here, but if you are academia, so maybe I give you some of these potential research problems for you to look at so that you can think that how should we continue to advance the area of analytics so that we can continue to make the Data Twin able to apply in a better way. So some of the research challenges that we have and our group is currently embedding. So one of the things is challenges is actually I call it computational efficiency. So why? It's because now if I have a Data Twin, and especially my Data Twin look into a lot of possible scenarios, and I want to optimize them at the same time, and you find out that the computation time will be very, very tremendous. So now one question coming into here is how should I optimize and improve in terms of my computation efficiency? So one example can be, when I need to have a multiple alternative and multiple scenario to run. So how should I run the scenario more effectively so that I can still help me to find a promising design or promising decision giving a limited time? And this is one of the areas we call a ranking and selection problem. Means I give you the care design, and each design I need to run simulation. I know simulation is very noisy. I need to know how long should I run, how many replications should I run. So this ranking and selection is to help you to decide how should you run more effectively so that you can pick few design or one design which are better in terms of the performance. Okay, there's one dimension. And the other dimension, I call it multi-objective optimization, and which is actually, just as I mentioned, that since your system is help the system to evolve, we know that system usually have a multiple objective they want to optimize on. So in this regard, can we try to embed the optimization or multi-objective optimization or better multi-objective optimization in my analytics, in my Data Twin, so that I can make a better decision? So this is the second dimension. And the third one is, when I have a multiple model available, which is high fidelity, low fidelity, and more tedious fidelity, can we try to optimize it simultaneously so that I can have a limited time to know which model I should use so that I can make a better decision? So again, this is one of the approach we are using and to help our transport to design one of the design concept, and eventually it has been endorsed by our head of civil servant for that particular project. And the underlying technique we're using beside the tool we built, and one of the very important analytical skill is a multi-fidelity model optimization. We embed in our whole model there. And the last one is actually, I talk about scenario based. And since we have to look at a lot of possible scenarios and so many scenarios need to run. So first question is how to generate the future scenario, and also how do we going to run the simulation effectively so that I am able to run my Data Twin effectively, even though I borrow time from future, but my time is still limited. So how should I actually run those future scenarios more effectively so that I can generate a good data for my AI to learn? And finally, simulation analytics is some question we are doing, which including how do we apply the simulation to learn from offline, and also just like I mentioned for the example that we just mentioned about the Go Alpha. If you learn everything through the online, it's not possible. The online performance will be very bad. So that's why you need to so-called combine when the situation has not happened yet, you're trying to learn, and versus when the situation really happened, how do you learn at the spot? So these are all the research challenges that we are doing. So because of time, I don't want to go through very detailed about what we did. So these are some of the research we are doing. So essentially, simulation optimization is about when a problem, we need to run simulation because there's no analytical form, there's multi-objective, it's scenario-based, and I have to run simulation and simulation for uncertainty, and also you have a multiple fidelity. So the concept here is how should I run the optimization and simulation together, and so that at the end of the day, I can output the decision which is good enough, which is robust, and can be applied to the problem that we are facing. Okay, the following few slides, I don't want to go through detail, but just to give you a sense of what kind of problem you're doing. So we deal with the problem when the simulation are not able to give you the correct observation, and because sometimes you might need to start the simulation halfway, so it means you might have some sensor data. So when making a sensor data, how should you run the simulation effectively so that to make a decision? So again, we have certain paper that we do the work and have been applied, and so the whole idea here is the approach we are developing is shown to be quite effective. And the second dimension we look at is actually in terms of multi-objective, and then we also develop many of the multi-objective search concept. So the whole idea about this multi-objective search is actually how should I try to design multi-objective search direction in such a way that I can get a promising design, those designs which are Pareto optimal in the more efficient and effective way. So that's the second what we are doing. And the third work that we are doing is also in the multi-objective, except that now we're using a different concept called the multi-objective compasses. So the whole concept here very interesting. He always trying to evaluate using the simulation to see where are the promising area that your decision should be. And eventually, he's trying to emphasize on those areas which have more promising and then gradually go down to the promising design. And the concept is called the multi-objective compasses. So another thing that we're trying to do is now, again, we have a multiple design. How should I run the design more effectively if I would like to identify which are the Pareto design? Again, these are what I call the multi-objective ranking and selection. So we also have published paper on here. So the other part, which is kind of interesting, is what we also doing the multi-objective, but we call it a robust ranking and selection. So the reason is because many times when people want to make decisions, they are not only trying to make a decision based on the average, but sometimes you might want to ask the question, hey, how about in the best scenario, if my decision I make is good? How about in the worst scenario? How about in the typical scenario? So in other words, when people make decisions, not only they look at a single scenario, but look at a multiple scenario at the same time. And when you look at a multiple scenario, each scenario might have a different weight, and each scenario might have a different importance. So in such a regard, instead of treating this as a single objective problem, I might want to treat it as a multi-objective problem. So again, we're trying to develop approaches when we have such a constraint, such a consideration, how should I make my decision more effectively, efficiently, and under such a situation? So this is something that just I mentioned. I'm using a lot of technique that we are developed before and help the TWAS to come up with design evaluation to design how the TWAS terminal should look like. Later I have time I show this thing. And of course, the next one is actually scenario based. And again, these two are actually talk about how we generate scenario more effectively in order to run the simulation optimization more computation intensive. And finally, we do certain offline learning and also some online and offline learning. Okay, I think these are very, very detailed. So those people who are interested in conducting research in this area, feel free, you can read the paper that I have, or maybe possible you would like to link up with me, and so that we can discuss about some of this collaboration on this research. Because I will believe that we are the center not only trying to provide a typical solution to solve a problem, but we also trying to embed this research outcome that we have in order to advance the digital twin technology. So essentially, how will digital twin help? It can help us become a test bed for the design for the next generation system. It can also help us to improve a system performance. And finally, it can also help us to test a scenario and how should we respond and how should we actually well prepare before the scenario happens. So let's try to introduce, we have an in-house tool that trying to build, which is called an all-desk. And this all-desk actually embed optimization inside simulation and also trying to put a simulation under the optimization and also do the so-called simulation analytic. So maybe I just have this small video to show you what we are doing here.
The orders framework helps in developing various port concepts and evaluating their designs. By embedding the optimization in simulation, it enables us to evaluate performance of candidate optimization algorithms, which derives operational decisions during the happening of critical events in the port, such as vessel arrival and departure, discharging and loading of a container, mounting and dismounting to a vehicle, and stacking and unstacking to a yard block. The orders framework is able to execute the corresponding algorithms at the right time, and make decisions based on simulated data observed from the snapshot data forming as the state. Based on the optimization results, it updates the state information by executing the decision, and schedule other events in the simulation at future times. It helps to evaluate various real-time decision-making rules, such as berth scheduling, yard space allocation, equipment dispatching, and vehicle routing, in a dynamic circumstance, so as to choose the best operational rules with respect to a specific scenario and port design. Whereas, through the optimization outside the simulation, we can alternate various port configurations, such as parallel or perpendicular layout, single or multiple trolley cranes, the number of the automated guided vehicles, and the stacking height to be operated in the yard. Through the orders framework, the optimization algorithms developed by our team will obverse the impact of alternative designs on the port, and eventually identifies the optimal design that leads to the best performance. In addition, by incorporating with the deep learning technology, the optimal decision can be trained as a response to the environmental or state parameters. Specifically, the training data can be provided from the historical database collected from terminal operation system, vessel traffic service system, and devices or equipment with the Internet of Things, which indicate what is happening, as well as the simulated state parameters which provide predicative look ahead, and the optimization results telling prescriptive water response. With integrated simulation and optimization empowered by deep learning on the three sets of information, the orders framework is foreseen to support operational decision-making in real time without latency. The orders model can be compiled from XML files for exchanging information, and further enhanced with large-scale databases and high-performance computing.
Okay, so based on this orders framework that we do, so we have done a lot in the port area, but we also have done for the warehouse area. So of course, one of the things that we have done for the one we want to emphasize is analyzability, and which actually including the optimization analytic in a different way. So that actually helped the data twin actually smarter. So now let's try to look into also one thing that we are currently doing. Actually, we are also trying to develop a DC suite, which actually trying to change the warehouse and then using the so-called markup language and then to describe a warehouse operation. And so this is the current work that we are currently doing. So let me try to using some time to demo some of the case study that we are doing. So, okay, we have been working many different problems with the industry based on our data twin work. Of course, one thing that we are trying to do with is actually look into their manpower planning. Even though just now I talked about automation, but for this particular 3PL that we work with, there are also one aspect of the warehouse automation, but there are also certain manpower that need to be there because certain processes still need to be handled by the manpower. So one of the main issue challenges for this particular problem that we are doing is actually how do they actually do their workforce scheduling, all this, and do the workforce scheduling changes according to the workload that they're having, and also they have some long-term employee and also the short-term one and part-time one. So how do they actually do the balance in order to optimize it? Of course, one way we can do is we can do optimization, but the other thing that we can do is actually actually, because there's a lot of uncertainty, things come into picture, and that's how we are going to simulating the whole operation in the warehouse and trying to optimize at the same time, so that at the end of the day, the warehouse manpower can be a better sale. So this is one of the problems that we're doing. And now we're also trying to not only optimize our warehouse, but also optimize in terms of where they should store their skill, as well as how do they need to do the so-called design of the buffer phase, and so that the whole warehouse can be efficient and effective. So this is one of the problem that we're doing now. And the other one that we're actually doing is we're helping one of these the shipper to look into the so-called new design of a warehouse that they are doing here. Because for this electronic manufacturing company, actually their whole factory is already automated, but their warehouse is still pretty manual. So now they want to build a new warehouse. So the question is, what kind of automated system they should have? So by working with us, we try them, we advise them with a different kind of automation system that should have that, and not only a single system, but it can be a combination of a few systems there. And that's where we're trying to advise them. Again, we tell them that if you're having these combination, and then what kind of effective you can have, and then since there's a lot of different objectives to look at, so at the end of the day, we show them how we should prioritize and how should you consider trade-off between the different objectives. At the end of the day, the warehouse decision can help you to make the best choice. So again, this company now already want to build the warehouse. So now we are going to work with them when the warehouse is actually up, and then to advise them how the warehouse control system, as well as WMS, and how the digital twin should be work together. So this is one of the work that we are doing now. And the next one that actually we're trying to work with is with the air freight terminal. And then again, we're trying to look into the productivity study. And one of the very interesting part about this work is after we start to work, and then the COVID-19 start to arise. And because of COVID-19, we knowing that now the passenger flight is actually going down, but however, the air cargo is still going strong. So there will be a lot of changes in their flight pattern all this. So it's just timely that we'll be trying to build this digital twin for them, not only trying to optimize in terms of manpower, in terms of schedule, but also look into, because of this COVID-19 and they change their flight schedule, are they able to still manage the kind of a volume they are going to handle? So are there any new choke point to come, and then whether are they able to meet the cutoff point that they're having. So this the air freight terminal actually are quite happy, and then they're even thinking about that, can they actually introduce the digital twin concept not only to their so-called Singapore terminal, but also can be to the Asian and other terminal that they'll be involved in. So the whole idea is actually like, can I actually use the digital twin to actually look into my current situation, how good they are, and what are the future scenario to look at, and can I actually try to evolve my system into better cells? So this is another example that we're having. Okay, so the last example that I want to introduce here is actually our work in the port.
Over the next 30 years, all our container terminals will move to Singapore's western tip at a megaport in Tuas. The land is still being reclaimed, but when it's fully completed in 2040, the Tuas megaport could be the world's largest container terminal. It will handle a higher volume of cargo and ships than all our current terminals combined.
Eventually, it will be almost a fully automated terminal.
Integrating all the new technology will be challenging. At the National University of Singapore, a pair of award-winning professors lead a team of engineers who model and simulate the operations of a megaport to find its optimal design.
Here, what we can do is that we're able to provide a detailed design through simulation and able to actually evaluate how good is this particular design able to perform.
So far, a lot of concepts that we explore, they have a pros and cons. It can handle the so-called automation issue, but on the other hand, he will incur you a very high cost.
The professors say the Tuas megaport will be designed to overcome Singapore's shortage of land and labor. Automation reduces reliance on human labor, and smarter, more intense land use will let the port handle higher volumes with less space. But controlling a dense, highly automated yard will raise new complications.
In future, we're going to have all the automated guided vehicle inside the port. You won't see any truck driver driving the truck around the port. And if you talk about automated guided vehicle, you need to give them a very good brain. in terms of control algorithm, where should you go? What happens if there's a congestion here, and what should you do?
Now the whole port is controlled by a brain, right? If somebody were to hack into the brain, right, then the whole system will be in chaos or will stop operation. So that's where cybersecurity becomes a very important thing in future.
Optimizing the future port's design is a work in progress. The Tuas Megaport is expected to begin operations as early as 2021, and it will be built.
Okay. So I think what I want to highlight here is these are all the work that related to digital twins that I've made in our center. And of course, the first part is many more on the warehouse, and the last part that will show you also the work that we did for the container port. But no matter whether it's a warehouse or container port, I think there's a one common feature here is actually we're always constantly to look into the future. And since the future is not about just the automation, technology, and robotic, but there's a lot more are going to happen because of the digitalization. So now we are actually riding the wave of digitalization. And what digital twin can bring us is not only trying to look into now where we are and what we are, but it can also help us to actively look into the future. So that's why I would like to conclude my talk here saying that digital twin is really the crystal ball, help us to see the future. So with this, I end my talk so that we can still have some time to talk, and also so that we will not delay the so-called workshop for further. Okay, so with this, I thank you everyone. Thanks.
Thank you.
Okay, thank you so much, Professor Lee. Is there any question from the audience? Any curiosity that you would like to ask Prof. Lee? Please raise your hands, and I will hand over the time to you. Okay, so we have one question from Juan. Juan, please.
Let me set up and the camera. I don't know if you can see me now. Can you hear me as well? Sorry,
yes, we can. Yeah.
Thank you. Thanks a lot for the presentation. And as I was mentioning, it looks a little bit like science fiction, in a sector like humanitarian, where I've been working for the last years. I think that there is potential, definitely, especially now that we are getting more and more data through the digitalization, as you were mentioning. What I was wondering is, for me, it was great to see the kind of the theory behind, and I understand from your academic point of view, there is a lot of mathematical models, and most of them they are based. The more data series, I guess, that you have in order to feed your data model, the more accurate it will be kind of the outcome. So the more inputs that you can feed into the system, the system could, as you were mentioning, even self-learning or setting up tools in order to learn more and more. However, in the humanitarian sector, at least in natural disasters, where we are responding, is more the unpredictability, and we don't really have so many events. Well, at least this is what we think, as a practitioner, and that's why probably it will be very interesting for you to maybe share a few ideas where you think that these techniques could be used more in the humanitarian sector, that compared to running a port or an airport that you have daily operations over years and years, kind of more or less repeating the same, like in an industry, you fine-tune, refine. So a little bit. Couple of areas that you think it could be interesting to start looking, maybe the low-hanging fruit. And I'm sure that in the next years, if we have a similar conversation, we will be able to tell to our share experiences where we have been starting to apply. Thanks a lot.
Okay. Thank you, Joan. Thank you very much. So I think you point out something quite of important, and is actually the application for these digital twins. So should it be only when you are more mature sector, or the sector which have a lot of data, a lot of knowledge, that you are able to deploy?
or would it be a very so-called expensive kind of solution? Only those big MNC and only those which are more advanced in their technology able to do. Actually, my feeling is this is not necessarily. Yeah, why not necessarily? Is because it come into something I call a knowledge. You see, because the knowledge is actually the basis for this digital twin. And when I say the knowledge, that's why a better way to talk about digital twin is actually it's more like our knowledge toward the system that we actually use a digital twin to represent. And the knowledge is always, there are two parts of knowledge. One part of knowledge is based on what I understand and based on the data that I have. And the second part of knowledge is based on my continuous learning. So one of the exciting thing about the digital twin is you based on your data you have and based on your primary understanding, you can build a primary model. And based on this model, you can start to ask a lot more questions to the model and let the model to learn by itself. So it means it's not only limited by the situation that you are facing, but it can also beyond the so-called physical boundary or physical border that you have. So of course, I understand that you're more talking about the humanitarian logistics. So I have to say that I'm not that familiar with the word. But one of the potential I can imagine is, I mean, during some of the disaster happen, so how are we going to quickly, for example, to disperse the kind of emergency supply to those people who need, and how am I going to recover the system in a much faster and a better way? So it really depends on what we are looking at here. Of course, sometimes it might happen that when every disruption and every disaster, maybe people say are different, and that's why when a disaster happens, you have to figure out how. Oh, sorry, someone mute me, so I have to unmute myself. Okay, so disasters are different, but on the other hand, I can also try to look into all the past disasters that have been happened. So can I accumulate the kind of the model relationship as well as some of the strategy that I can use, and then I can look at what is actually happened in the past and try to learn and try to optimize. And then based on that, then I can start to have my model or my knowledge toward different type of disaster. What can be the probably impact and probably issue, and what will be the possible way to do. So if today I have a digital twin, which is actually a cumulative kind of a knowledge, maybe I start small, but when I have accumulate more and more knowledge, then I can have a lot more bunch I'm doing. And sometimes I can even learn from some other incident or some other disaster which might appear to be independent, which might not be relevant, but some of the knowledge we learn can be applied. And that is where I'm exciting about that is I don't see digital twin is just about representing a physical system or physical situation in one single model, but rather can I have a platform model, I can have this to combine all the data and the model that I have, and eventually they can interlink and they can learn by each other, and this is what I call a knowledge hub. And that's why if you look at my concept about all this, what I want is actually we have a lot of research, and this research have become some kind of knowledge I can embed and I'm able to access to, and so that I can try to find the best way and best tool to solve the best problems. Just I mentioned about transformer, I really hope that we can have this machine module combined together and then can fight for future. And these machines are going to fabricate itself to more machine, more module, so that no matter what kind of a monster are going to come in future, we can always sustain against the monster and fight against that. Okay, yeah.
Thanks a lot. Just really kind of one small comment from your advice.
Yes.
As you were mentioning, it could be very expensive, and for humanitarian organizations, we don't really have so much of budget in order to devote to even start. I mean, it was very encouraging for you to mention, I mean, let's start with something and later we will be organically learning more.
Yeah.
Do you think that probably then for humanitarian organizations like the Red Cross, it would be better to engage with the academia, with universities in order to start rolling out a little bit rather than investing in kind of private sector, kind of more from a supplier vendor relation?
I think definitely it can be of course for the short-term solution, it's always you want to find those vendor can give you a solution fast. But if you look into something long-term, more on the future and forward some of the field technology to be there, then working with academia is still actually is something good about that. Because of course the pros and cons, the good thing is actually because we are not limited by the current technology, we can actually look beyond. We can even try to come up with a new technology for the future.
And I think this is very important, and this is something that's the thematic area for all these workshops, is because when you go to the vendors, yes, you will get something today and you'll get something fast, but it's not actually tuned to your operation. And I think what you said very nicely is that you don't make the operation tuned to your model. You tune your model to the operation, and therefore you can open the box to actually look at what other possibilities are. I mean, the downside is, you said it, that it takes time, yeah, but that's important. Thank you for elaborating on that, because the humanitarian sector is a very difficult sector, but it's also a very nice sector because the collection of data is very fragmented. And it's like our logistics industry in the past, So it's fragmented, and so putting that together is quite a challenge.
Thanks, Bob.
You got your hand up here.
Temo
here. Hello. Thank you, Professor Lee, for this insightful, talk. My question, comes from the topic of this smart warehouse. Like, you can see in the Amazon or JD.com in China. So, basically they have this environment where, robots and human work together. So we call it like, parts to picker robot in mobile rack environment. So in that situation, this question is about from the optimization perspective, because I've been working on this research problem where there is a queue of this, robots in front of the picker, right? What's your thought in actually optimizing the entire situation? Like maybe going ahead with, proper scheduling, right? Maybe deploying, appropriate number of robots in the environment, or like appropriate number of workforce. So what are your thoughts in this setting?
Okay, so Temo, thanks for your question. Actually, I would say that if you really look at the smart warehouse, of course, now the most part of people actually talk about smart warehouse is actually to deploy so-called the robotic and to coordinate in the warehouse. And that's what they call a smart warehouse in a large scale. But of course, generally, in order to employ such a robot there, you need to have certain sensor systems so that there won't be any accident happen. So you should have certain rule base, to coordinate in such a way that, we can make it efficient and effective. So I would say that generally, when you look into a smart warehouse, especially if a smart warehouse is not a big scale, usually it's still okay because they're a simple rule usually can do a good job. Now you might not see a lot of chop point here, so that's why it's still okay. But however, if you really look into a much more complicated system, and then just give you one example, like the container port, which is also a huge warehouse, you can think about that. And then a lot of equipment are so-called automated, like for example, AGV. You talk about the key crane, yard crane. It's also a huge warehouse we're talking about. It's also an automated warehouse in that sense. But however, for such a warehouse, you realize that if you do not actually embed a lot of so-called the smart rule into the so-called system itself, and then just using certain gut feel rule or the experience rule, and then you might not be able to exploit the advantages of the warehouse or the port into a fuller extent. So that is where potentially optimization and computation will come in picture. But to be true that sometimes you ask me, can I do a real-time optimization in the smart warehouse? My question is still not there yet. The main reason is because when you want to do a real-time decision, you need to do it in terms of seconds and minutes. And I always told my research fellow as well as my students saying something. Whenever you look at optimization problem or decision problem, you always have to ask three things. IoT. Okay, my IoT is not Internet of Things. It's input, output, and time. Okay, what do you mean input? Means what kind of information you have to be collected in order for you to do the output. Output means what kind of decision and you want to let people know. So is the decision about how do you do the dispatch or do the routing or here. So this is about output. And the last thing is very important. It's a T, means the time. So how much time you have in order for you to make the decision. So a lot of people say real time, but the real time can be in terms of second, but some real time can be in terms of millisecond, and some real time can be in terms of a minute, some real time can be in terms of hours, and some real time can be in terms of days. So if you look at the different time requirement, then the way how optimization can be embedded will be different. And I will envisage that actually if you look at the optimization and the AI together, actually it should be one body. So it means what? Means a lot of time we say AI is my neural network or machine learning. So the whole idea about the machine learning is to find relationship. So it's a like regression function, find relationship. So it's a memory. So for example, I have a table, I tell you this, I do that. So now you look at the T, how much time I have. If today my time is very short, so what I want is actually a very fast function. When I key my input, immediately tell me the output, then I execute. So in that case, you don't actually need to do much optimization. But however, if the time today changes from second to minutes to hour, then I can do a bit of optimization based on the timing I have. So in this case, possible I can using my learning to do certain reformulation about the model, or maybe start with certain good decision. Then after that, I can using the limited time, can be hour or minutes, to do my optimization related to that. So if you really want to look at a more holistic way, it should not be just say, hey, should I use optimization or not optimize? It should be problem dependent, which depend on I and O and T. And you should have a good combination of the online versus the offline. Just like if you hear that I talk what's the last part is actually about the offline online, which is important because offline can help you to memorize, but online can make you to use the most latest information. However, how much you can do online really depend on the requirement of a T. So in a nutshell, this is the best way if you want to increase the smartness of a warehouse. So in summary, if you have time to continue to run, your offline should be continue to learn and learn and learn. So to make yourself better and better. And online is actually depend on the time, then you should immediately learn what you need to learn at that time so that you can create in the faster way. So this is my envision about how the real time optimize to go to. And that actually come into just like I mentioned about the future trend is actually when 5G come. When 5G come, you are going to have overwhelming of the data. And when you have overwhelming of data, this question definitely will come. Means how should you better utilize the data information and the cloud computing and also the online computing and the offline computing together so that in the limited time T that you have, you met the best result from that. And this is actually what I feel the future about the smart warehouse or smart port or all the smart system are going to move toward. Yeah.
Yeah, totally agree, Professor Lee. I mean, thank you very much for this suggestions. Yeah.
All right. Is there any additional question? Thank you so much, Prof. Lee. Thank you, Tarmoy. Anyone else? Any curiosity or question for Prof. Lee?
Okay. So as I mentioned, if you have any question, can send email or this. Yeah. So for those people who are interested in the container port, so just things that we are going to organize one of called a port ML port markup language symposium by the end of a month. I think it's August 30th. So if you're interested, actually, you can send me email so I can let you know more detail. But that one will be pretty much focused on the container port, which is actually August 31st, which is actually a national day for Malaysia. Yeah, August 31st afternoon. So if you're interested, you can let me know so I can link you out with our building list. So that will be pretty much on the port focus on port digital twin and about some of the technology that we developed for the container port. Okay, yeah. So thank you very much.
Thank you. So maybe we can hand back to Young or Giuseppe.
Yes. Thank you, Prof. Young, over to you.
Paul, would you like to carry on the next session or for a short break?
I suggest we take a short break of 4 or 5 minutes, so to give this will space you time to load up the slides too.
Okay, sure. And before we go for a short break, can I request everyone to listen on your camera? I'd like to take a group photo. I think most of the participants are with us now. This is a good time for a photo. So my colleague, the TP will help us about to take it. We'll take 1 or 2 minutes of presentation.
Yeah, let's take our camera and take a group photo together.
Okay, please continue to look at the camera. Stay with us for a while.
Okay, thank you. Thank you, everyone.
Thank you, Ting Yi. Thank you, everyone. Okay, for the sake of time, let's go for a very short break. Take a 5 minutes. And we will come back here in 5 minutes time, and the next session from by Dr. Tan Pui Siu will commence at 11:50 a.m. Singapore time. Thank you very much.
Chair, can I share screen and test out a video while the break is on?
Absolutely. Please carry on.
Okay, can you see my screen well now?
Yes, but your sharing mode needs to be adjusted.
What are you seeing?
I'm seeing all your little slides at the side. What mode do you call this?
Yeah, I have not gone into presentation mode yet.
Okay,
Yeah.
okay. But it's good, it's good.
Yeah, okay. Let me test out the video because that's the bandwidth gas, yeah?
Sure.
Okay, let me find the video. Okay, I've no, sorry, wrong one. Let me get it to the correct one. Okay, I put the videos onto different file because otherwise it's too big. Let me know. Are you
Digital
hearing it
technologies have ushered in the fourth.
Are you hearing it well?
Yes, loud and clear.
Is the video screen big enough?
Well, it looks all right on mine. But did you pause it or is it
Yes,
lagging?
I pause it. So
Okay, okay, okay.
Yeah, so it's good. Yeah, okay, then I'm good. Yeah.
But it's not the full screen though.
Yes,
it's intentional, right?
We prefer it in a full screen so it's easier for me to manipulate.
Okay, cool.
Because I've got a few videos that I've taken that out of the file. Otherwise, the file becomes too unwieldy.
Okay, in that case, I think it's very good to go.
Okay, all right. Okay, thanks.
Thank you.
Yeah. Yep, I'm ready when you let me know. Yep.
Okay, thank you.